Okay, let's do a quick introduction to working with strings. So I'll show you how to break a string into multiple pieces, how to search for particular things inside a string, and how to extract sequences of characters within a string. So first let's talk about splitting strings. I covered a little bit of this in the video about loading text files. I can take a string like message2, and I can split the string into parts whenever I see a certain character or sequence of characters. So here I'm going to split it whenever I see a comma. And the result is going to be a string array that contains each of those pieces, or it contains each of the strings that happen between the part that I'm splitting on. So for example, here I'm splitting on comma, which means that vals is going to be an array of 3 elements. Element 0 will be this, element 1 will be that, element 2 will be that. Just to see what that looks like, let's loop through it. So less than vals.length. So let's look at vals element I, and we'll print it out. Okay, so as you can see when I run it, I've got 12, and then a space followed by ASDF, and then a space followed by 34. For example, if I wanted to split on comma space, now when I run it, you'll see that there isn't a space before the A and the 3, because that's part of what I'm splitting on. Let's do this. 1 and 2 and 3 and 4. So here, if I was going to split on the word and, you'll see that it's just got 1, 2, 3, 4. If I was going to split on and space and, or sorry, space and space, then this is the part I'm splitting on, so it's really just giving me back the words that are in between. If I wanted to split on space by itself, it's going to give me back a list of each of the individual words. And finally, if I'm going to split on the empty string, so there's nothing in here, not even a space, that gives me a list of each of the individual letters. So this is a very powerful technique because once you have an array, now you can loop over the array however you want, forwards or backwards. You can test individual letters for things. So that's a good technique. Okay, so let's say I've got 1, 2, 3, 5. I'm splitting on comma, and so it looks like this. What if I want to ask the question whether or not a particular element in my array is a digit? I should mention that there's something called regular expressions, which is a kind of a pattern language that's used a lot of times for matching particularly complicated patterns within strings. I think in a lot of cases, regular expressions are absolutely essential, but for the simpler tasks that we're likely to be doing, they're probably more trouble than they're worth, so I'm not going to talk about those. So we're going to be solving all of these problems without using regular expressions. So I'm going to show you kind of a trick you can use to test if something is an integer. Let's do this. So you remember that you can say integer.parseInt, and that if you give it a string that actually represents a number, it will take this string and convert it into an integer. But if I give it something like this, let's watch it crash, it'll say number format exception, because you can't give it a string like A and have it turn that into a number. So let's use this idea. I can put this statement inside what's called a try-catch block. So here I've got try, and then an opening curly brace and a closing curly brace. And then I can say catch exception E, and then another opening and closing curly brace. And you have to exception. Got to spell exception, right? So what's happening here is I'm saying let's try to do the code between these two curly braces. And if there's an error that happens while we're running, such as this number format exception, instead of just crashing, it will jump to whatever lines of code I have after the catch. And so I can say something like this. So error. And so we can watch and see how it just says error, 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 but it didn't crash. And the error is happening because I can't parse the letter A as an integer. So the idea that we're going to do is we're going to turn this into a method for testing whether or not something could be an integer. So here outside of main, I'm going to say public static boolean is integer. And we're going to take a string as an input. And what I'm going to try and do is I'm going to try and have this same code, and I'm going to take whatever the string that's an input is, and I'm going to try and parse it as an int. And if it works, then we won't run the catch part, because the catch part only happens when there's an error. So if this works successfully, what that must mean is that this can be parsed as an int. And so in that case, I'm going to return true as a way of indicating, like, yes, that thing was an integer. If it goes to the catch portion, that must mean there was a problem, so I'll return false. So now I've got this nice method, and I can do this. If is integer val, then I can say system.out.println val is an integer. And so now we can sort of watch what happens. So I run it, and it says 1 is an integer, but it looks like, why didn't it detect that 3 is an integer, right? Because that should have worked. So let's try and investigate what's happening by going back and printing all of our strings again. So 3 isn't just a 3 by itself. It's got this space before it. So it turns out that if you try and parse the string space3 as an integer, that also fails. So I'm going to show you a trick. You can run a method called trim with no input on any string. And what that does is it would remove any white space at the beginning or the end of the string. That's usually called leading and trailing white space. So it'll just remove those spaces. So here, if I run it now, you'll see that it's removed the space before the 3. It's still not detecting that it's an integer, but that's because when I trim the variable, it doesn't actually change the value inside the variable. Instead, what it does is it returns a new copy of the string that's been trimmed. So if we want to trim it, we've got to do this, val equals val.trim. And now when I run it, now I'm detecting that 1 and 3 are integers, but it's not crashing for 2 and 5. You could add an else here, so system.out.println, so val is not an integer. Great, so 1 is an integer, 2 is not, 3, 5. Cool, so that's one way you can test to see if something's an integer. What if I wanted to test to see if something was a vowel? There's a nice method called contains. So up here, I've got message 1 is the same, and I'm asking, does message 1 contain a lowercase w? And when I run it, it displays true. Does it contain an uppercase w? The answer is false. And it doesn't have to be single letters. You could say, does it contain the 2-word sequence TW? And the answer is true. TWU? And the answer is, again, false. So it's a great way of testing, does this thing contain that thing? So what if I wanted to count the number of vowels in here, for example? Here's one way we could do it. Let's not split on comma, let's split on nothing so that we're breaking this message into individual characters. And let's loop over all the characters. And then it would be nice if we could ask something like this. If val is a vowel, then we'll add to a counter. So how do we ask if something's a vowel? Well, we could use contains. We could say if the string A-E-I-O-U contains our unknown character. So this is sort of a counterintuitive way of using it, but I'm asking, does this list of vowels contain the single letter that we're looping over right now that came from our original message? And if the answer is yes, then it must mean that that was a vowel. And so I can add to a counter, which I'd have to declare up here. Pop. And then at the end, I could system.out.println counter. So now it says 3 because I've got an O and an I and an E. What happens if I've got some uppercase and some lowercase? In this case, it's still just, it says 2 because I've got a lowercase o and a lowercase I, but it's not detecting these uppercase ones. Of course, you could add uppercase versions here, A, E, I, O, U, and then that would work. A different thing you can do is you can force your entire string to be all uppercase or all lowercase. So for example, I could do this. I could say message1 equals message1 dot to uppercase, and that forces everything uppercase. Or I could say to lowercase, and that forces everything lowercase. And so now when I run it, it's detecting 4 because I've forced everything to be lowercase. Another important method is called indexOf. IndexOf will search every character starting at the beginning, searching for whatever string you have here, and it will return the location number where it finds that first thing. So I'm looking for commas. So here when I run it, you'll see it says 1, because you can think of a string sort of like an array. The first character is at index 0, or location 0. The second character is at index 1, or location 1. So this has found the index of the first comma. If I want to know where's the first space, and I run it, it says 2, because this is 0, and then 1, and then 2. Well, what happens if you want to know like the location of the second comma, for example? There's a different version of indexOf where you can tell it where you want to start searching from. So I'm searching for a comma, but I'm going to start at location 3. And so it's telling me location 6 is the first time we see a comma if we start our search at location 3. So this is kind of handy because it will, well, this combined with something else is kind of handy. Let me show you the other thing that you can do. There's something called substring where you tell it a starting location and an ending location. So here I'm starting at index 2 and I'm ending at index 4. Let's end at index 5. So 2 would be, or let's start at 3, I guess. So 3 would be, this is 0, 1, 2, so 3 is here, and then 5 would be here. So I'm going from this uppercase O to that lowercase o. And when I run it, you see that it's extracted just the letters at locations 3 and 4. When I say I end at 5, that means I don't include 5. Like I'm really ending when I get there, and I'm not including that as part of what I'm getting out. So this is a nice way of extracting things from the inside of a string. And this is very powerful because you can put those two techniques together. So I can ask my message1 for the index of the first comma that I see, and then I can save the index of the second comma that I see. Oops. So I'm going to search for a comma, but I'm going to start my search at the location I saw the first one plus 1. So I'm going to start at location 1 after the first one. And then what I can do is I can make a variable called between, and I can say message1.substring starting with first and ending with second. And so let's see what that looks like. So here's the first one, here's the second one, and it's gotten everything between them except it's included this comma because I told it that it should start at the first index where I saw a comma. So actually maybe I want to start 1 after the first index where I saw a comma. Great, so now I'm getting space OWO, which is exactly what's between the two commas. What happens if you search for something that's not there? If I search for like Z, for example, message1 index of Z, it will return -1 as a way of indicating that there is no location of Z inside message1. So lastly, let's figure out, so we saw one way of getting out everything inside of between the commas. You could split the string on comma, and that automatically makes an array. Let's look at another way we could do it. I'm going to use a loop. So I'm going to keep looping while I still see commas in my message. So I'm going to say while message1 dot contains a comma, I want to keep doing this. And what I'm going to do is I'm going to get the first comma, and I'm going to get the second comma, and I'm going to get out the string that's between them, and then I'll display it. And then I'm going to take my message1 and I'm going to replace it with with only the characters that happen after that second comma. So I'm going to say substring. So I'm going to start at location second plus 1, and I'm going to go all the way to the end. So one way I could get to the end is I could say message1.length. If you leave that off, substring will start at this location and automatically go all the way to the end. So one more time, what I'm saying here is I'm saying as long as I've got a comma, let's go ahead and get its location, and then let's get the location of a comma that happens afterwards. Let's extract the string that's between them. Let's print it. And then let's replace our message with only the ending of the message. So I'm going to start at the character after the second comma, and I'm going to get out everything from there to the end. And that's my new message 1. And so now when I loop back up to the top, I'm going to do the process all over again, only I'm going to do it with just that part of the string. So let's run it, and you'll see it's going to crash. Cool. And the reason it's crashing is because I'm only asking if we contain 1 comma, but then I'm trying to get 2 commas. So this would work if I had 2 commas, or let's do this. So blah, and then good stuff, and then blah, and then good stuff too. So now I've got an even number of commas. I've got this pair, and then I've got this pair. And when I run it, now you see it's getting good stuff and good stuff too, because I'm getting everything between the first pair of commas and then everything between the second pair of commas. If you wanted to handle the other situation cleanly, an easy thing to do would be, you could say, if second equals -1, that means that we didn't find a second comma. So you could break out of the loop. Break is a statement that just exits your loop. Cool. So yeah, so now I've got 3 commas, and it still hasn't crashed because it gets everything out between the first 2, but then it notices that there isn't a second comma after this first one that it finds, and so it exits. Okay, hopefully that's a whole lot of flexible stuff that you can now use to manipulate